Hello class, this is a video tutorial on local maxima and minima, part 2. In this video we'll be determining whether points are maximum or minimum using the derivatives. So, given some point f prime of x is equal to 0, then some point p a f of a is a local maxima if f prime of a is greater than 0 to the left of p and f prime, that should be f prime of x is less than 0 to the right of the point P. It's the other way around for some point Q is a local minima if f prime of x is less than 0 to the left of P and f prime of x is greater than 0 to the right of P. So let's focus first what it means here. So we have some points, it's a maximum. If we pick another point to the left of it and we find the derivative of any point to the left of it, we'll find that it should be a positive gradient to the left of it, so it's increasing to the left of it. And if we pick a point to the right of the point P, any point, it should be decreasing. It's the other way around for the point Q, which is a minima. So if we pick a point to the left of it and take the tangent of that curve, the gradient of the tangent to that curve, it's decreasing to the left, and then to the right of it, it should be increasing, like so. In the previous the previous video using function values, we found that it's possible to determine whether it's a global maxima or a global minima. However, using the derivatives, there's no possible way to determine whether a point is a global maximum or a global minimum. So let's get straight to some examples here. So in order to find whether a point is a maximum or a minimum, we first find the derivative. Here we are. We factor and solve for f prime is equal to 0, which is what we did here. And we found that there are two stationary points at x equals -1 and x equals 5. So now we'll be making a derivative table, and we're going to pick the points -1 as our critical point and 5 as our second critical point. And we already know if we substitute these two values into the derivative function, we will get 0 for both of them. And just so we can draw what this will look like, this is a stationary point, so the tangent is like so. Same goes for this one. The tangent is like so. So they're both stationary. Now what we need to do is determine points to the left and right of these respectively and figure out what their values are in the derivative. So let's pick a point to the left of -1. So let's pick the point -2 and the point 6 above 5. And to save us time, we'll find a point in between both -1 and 5. Let's just pick the point 2. So now those are the points we'll be testing into our derivative function here. Because it's already factorized, let's use this one here. So let's substitute -2. -2 plus 1, -2 minus 5. That gives us 7, which is positive. So that will give us an increasing gradient like so. Now if we put the value of +2, so +2, let's hope this works. Let's delete all this. So let's put 2 plus 1, 2 minus 5. That's -9, which is negative. So that's a decreasing gradient. So we can already see that this point here is a maxima because it's increasing stationary, and then decreasing. Let's find one last point to verify if this point here is actually a minima. So let's substitute the value of 6, so 6 plus 1 here, and then 6 minus 5. That gives us the value of 7, which is positive, so that's an increasing gradient like so. So we can see a very rough sketch of this is like so. Notice how this method, we do not know the y values for our maxima or minima. We just know that we can write this x equals -1, that's a maxima, and x equals 5 is a minima. We don't know whether or not those points are, we don't know the y values for those points using this method. If we wanted to, we could substitute those values back into the function to find their y values. But all we're looking for is whether they are maxima or minima. Let's move on to the next example. I've already factorized it here and solved for the critical points. So if we substitute these 3 points into the derivative function, I know these will be 0. And I also know that those will be stationary points like this. So those are all stationary. So all the points that we need to determine are the ones in between and above and below. So let's pick the points -1, 1, 3, and -3. So let's use this. I'm going to use the factorized form here because it's a lot easier to substitute into. So let's substitute -3 for x into here. So it's going to be 4 times -3, -3 plus 2, -3 minus 2. That gives us -60. That's a negative. So we know that's a decreasing point. Let's substitute -1. So 4 times -1, -1 plus 2, -1 minus 2. That gives us a positive value. That's positive. That's increasing like so. Let's substitute the value of 1. 4 times 1 times 1 plus 2, 1 minus 2. That gives us a negative. That's decreasing. And lastly, we'll substitute the value of 3 into this. So 3 times 3 plus 2, just substituting it from here. 3 minus 2. That's a positive, so that's increasing like so. So a very rough sketch of what this might look like. So it's decreasing, stationary. Here's increasing, stationary, and then decreasing, stationary again. So we have x equals -2 and +2. Those are minima, because that is decreasing and then increasing like so. So you can see, you can kind of visualize that this point here is dipping down and then back up. So those 2 points are minima, and x equals 0 is a maxima. So I hope that gave you an insight into determining whether points are maximum or minimum. And also, just as a reminder, notice how this method does not tell us at all what the y values are for these maxima or minima. Hope to see you in the next video. Best of luck.